Hello, I am Erik van Sebille, and together with all the fine colleagues listed here, I am part of the SCORE working group on floating litter and its oceanic transport analysis and modeling, in short FLOTSAM. One of the goals of FLOTSAM is to identify gaps in our knowledge of the near-surface ocean dynamics that may affect litter distribution and transport. And that is what I would like to discuss in the next 6 minutes. What you see in this spaghetti plot are the trajectories of drifters floating on the surface of the ocean. These drifters are GPS tracked and transmit their location every 6 hours via the satellite. In total, there are 20,000 of these drifters, and they cover the entire globe. This dataset has taught us a lot about where ocean currents transport plastic, but the drifters don't tell us why they move the way they do. What physics drive them? In my group, we create physics-based simulations of how ocean currents transport plastic around the global ocean. Most of our work so far has focused on the surface of the ocean. In this simulation, for example, Victor Oning tracked how plastic that starts out uniformly distributed over the ocean slowly accumulates in the centers of the gyres. Many models replicate this accumulation, and it's also been observed by groups that go out to sea and use manta trawls to measure the concentration of floating plastic. But why does plastic accumulate in the centers of these gyres? We always explain this with the so-called Ekman Theory. In this Ekman Theory, the easterly trade winds near the equator and the westerlies in the subpolar regions lead to a gyre in each of the 5 basins, where water slowly circulates towards the center. And as the water sinks, the floating plastic stays behind, accumulating in what are often referred to as garbage patches. Compare it to the turd that won't flush. But this is a fairly simple theory, and there's so much more to oceanography than just the gyre circulation. The Ekman Theory can't explain why the accumulation regions seem to be on the eastern side of the North Pacific, but on the western side of the North Atlantic. Something more must be going on. There's a plethora of transport processes and mechanisms in the ocean that all play out at different scales. How these different mechanisms interact is what we wanted to explore in our SCORE working group. So how do we go about if we want to find out how everything we know about ocean surface transport applies to floating plastic? Well, you start with the literature. We went through 395 peer-reviewed articles, covering everything from ocean gyres to rip currents and from breaking waves to pancake ice formation. We grouped these into 10 different categories of physical transport processes, plus a bonus category for transport by organisms. Some of these processes operate only offshore, like the large-scale open ocean processes such as the gyre circulation. Others operate only on the shallow littoral regions close to the coastlines. And some, like vertical mixing, operate in all depths. We highlighted some processes that we feel should receive much more attention from the scientific community. The Langmuir Circulation is one. Langmuir cells accumulate plastics in very narrow windrows, and although this is regularly observed at sea, it's completely unclear on what scale this is happening globally and what the effects of this heterogeneous distribution of plastic has on marine organisms. Another set of processes that should receive more attention are the coastal processes. How does plastic cross the surf zone? And what is the relation between a concentration of plastic on a beach and a concentration just offshore? A third set of processes are those associated with plastic in sea ice. How does plastic freeze into ice flows? And how do these ice flows then transport plastic through the polar regions? And what happens if plastic melts out of the sea ice again? And finally, the role of biology should receive more attention. Not only the sinking of microplastics through biofouling and aggregation, but also the long-distance transport by megafauna. It might be that the magnitude of this fauna-mediated transport is dwarfed by oceanographic transports, but at the moment we just don't know. Answering all these questions is beyond the scope of one single research group, or even one single community. to really understand how ocean processes transport plastics and what that means to the large-scale and small-scale accumulation of the plastic and the emergence of hotspots, we need to work together as communities. We need expertise, input and data from remote sensing, from ship-based sampling, from numerical modeling and from lab-based experiments. Because you know, my main message is this. The plastic littering our ocean is an atrocity. Society should be ashamed. But at the same time, the plastic is a unique opportunity to better understand how the ocean works. Let's seize that opportunity. Thank you.